has slowed, so let's go ahead and get started. Good morning, good afternoon, good evening, depending on where you're joining us from, and welcome to our newest CA IDMS webcast. Before I hand you off to Dave Ross, who's a product owner, just a couple housekeeping things. First, it looks like most of you are listening to this via the audio broadcast, which is great. That means you can ask questions verbally, so if you do have questions, please use the Q&A box right in the WebEx to ask your questions. If you don't see that box in the lower right of your screen right now, go ahead and click on the question mark icon in the upper right and it will open up for you. Please do use that rather than the chat. It's just easier for us to track. But please feel free to use it throughout the session, and I'm assuming that we'll stop at the end and get as many answers for you guys as we can. Also, just a quick reminder, for those of you who are on the phone line, to just please stay on mute until it's time for questions. I'll let you know how to unmute your line. Because we are recording this so we can use it and we can post it in the community later. And with that, I'm going to hand you off to Dave Ross, Senior Principal Product Owner for CA IDMS. Take it away, Dave.
Okay. Thanks, Len. Good morning, everyone. Today we'll talk about IDMS services based application development and modernization. Here's our agenda. We'll touch a little bit on why you might like to do this. I think everybody pretty much knows that already, but there is a strong business case to be made to your management. And then we'll talk about leveraging IDMS databases and how you can build services that access the data using IDMS SQL and Server. Then we'll take a look at leveraging IDMS applications, how you can reuse your business logic with IDMS either as a consumer of a web service or a provider of a web service. And then as Les mentioned, at the end we'll have some time for some questions. Okay, well, you all have a large, very large investment in IDMS. Sometimes people call legacy applications. I always like to think legacy just means it actually works already. But you know that converting from IDMS to another solution can be very costly. It can be risky. Things might not work. And you can find sometimes customers will convert and find they spent a lot of money to have exactly the same functionality, which is a very low return on investment. But there is the problem that legacy skills are very difficult to find in today's job market. So one way to address this is to, modernize. And by modernize, we really mean leverage or extend what you've done. Leverage that investment, preserve your existing applications. They run. Why break them? But enable web and mobile applications that can be developed using current developer skills. Okay, well, as you all know, the traditional IDMS world pretty much looked like this. You had green screen, Internet task code for online applications or the CICS equivalent, as well as batch jobs that access the database directly. But in the future, everything is based on APIs, which is sort of the way we talk about services in many cases now, where service is exposed through an API. These APIs can be consumed by a variety of devices that could include, web-based applications. More and more, those APIs are consumed by apps running on mobile devices, whether they're tablets or actually just smartphones. And they're really just connected through the cloud. The Internet means we don't really know where our endpoints necessarily are when we're running these. But what we're trying to access is the data that's in IDMS and the reuse, in many cases, the business logic for the IDMS applications. So the way we can do this is to create services, expose these as APIs. These services can access IDMS databases, and they would use standard interfaces that many developers know nowadays, including SQL, JDBC, ODBC, and also to access the IDMS applications. And in that case, what we're trying to do is create APIs that would expose the existing business logic in a way that can be consumed by, one of those application or apps running on a mobile device. So we'll start and we'll talk about leveraging IDMS databases, okay? And it's possible to create data services that access IDMS data directly. You can create these services using Java or .NET or even Windows directly. But these are, these would be hosted in common application servers such as Apache Tomcat, Web Services Application Server, there's WebLogic, there's a number of solutions in the market. IDMS SQL provides access to these network databases, and it's now included in the base license for all users. That is a really positive development, I think, for most users, because now users can take advantage of this, and we know that our users can take advantage of this. IDMS Server provides the connectivity to IDMS from these application servers, and it too is now included in the base license for all users. Using these tools, you can also use popular frameworks such as Hibernate with IDMS. We'll see quickly how that works. So this sort of a subset of a diagram, we often show how web services can access IDMS, and in this case, we're really kind of fine-tuning it just to show how a web service can access IDMS data in an IDMS database. And this kind of ties together what I just talked about. The consumer of the web service would connect to a application server that is typically running on a distributed platform, but that application server can also be running on Z-Linux, it could be running on ZOS, as well as Windows or Linux-type platforms. And that web service could be built using many of the popular .NET and Java tools that are really provide a lot of capabilities to build these applications. And it will then use the JDBC or ODBC to access IDMS to execute SQL commands that can access and update your existing network databases. So let's take a quick look at how you can do this. It's really easy. You just create a special type of SQL schema that names your network schema and optionally can identify the database instance, the DB name or segment where the tables are. The schema is defined in the SQL catalog, and as soon as you do that, every network record automatically appears as a table. You don't need to do anything else. You don't need to create those tables separately. You don't need to copy those tables someplace else. It's just they're directly accessible where they are, where they're being maintained by your current applications, except that now you can use SQL. And for example, example from our EMP demo or EMP scheme database, the employee record is in a calc record, so the equivalent of an obtained calc would be just a simple select star from EMP SQL, that's the schema we just created, to point to the network schema. And then we have a where clause, a predicate that just identifies the calc key and the value we want. Okay, so when we do this, we talk a little bit about mapping relational objects onto network objects. Okay, well, a table is a record definition. A row is, as you'd imagine, a record occurrence, just a row. Elements are automatically renamed to be columns. There's a couple of exceptions, the most significant of which is occurs depending upon, is not directly supported, but fixed occurs are. And we also have to pick, because there can, in a COBOL program, you can redefine elements and you can have synonyms defined in your dictionary. Well, in SQL, we have to pick something. So we typically will pick either, if you have an SQL synonym defined, we'll pick that. Otherwise, we'll pick the lowest level element. And then there are sets, which define the structure between records in the network database. And sets are analogous to referential constraints. So there's sort of partial mapping, but in many cases, the thing that defines a referential constraint, meaning foreign keys and primary keys, are not necessarily there in a legacy database. Okay, and that's now in the relational model, as you know, referential constraints are based on explicit data values in the database, meaning that in the employee table will have a column we call a foreign key. That foreign key contains the value of the primary key of a related table, in this case the referenced table. This is kind of analogous to a owner-member type of structure where the referencing table is the member and the reference table is the owner. Well, that works great for SQL-defined databases, but for network databases, sets are typically maintained by pointers, explicitly for chain sets, in which case the pointers next, prior, and owner are not in the data portion of the record, they are in the prefix. And as such, even though they are accessible to a network program that's using network DML, they're not exposed generally through SQL, because SQL, they're not user data, they're system data, and SQL doesn't expose that. So we've developed a number of techniques over the years to address this. Syntax extensions, the most common is what we call a set name predicate. You can use views in particular to encapsulate the syntax extensions and do other things like rename columns and implement row-level security and hide columns, etc. We have a couple of different types of procedures. We have something we call table procedures and something, just for contrast, I call call procedures. Those are really procedures much like that are invoked much like stored procedures are for other databases. And finally, we have a couple of different techniques for providing foreign keys for network databases, including referential sets and virtual foreign keys. And we'll talk about these in various levels of detail in the next few minutes. Okay, syntax extensions and views. Here you see how we're joining three tables from the employee demo database that we've accessed through a schema that we've defined. Those tables are now in the from clause, and then we have a predicate where we say where, and we're showing the set name. Rather than showing a equality between a foreign key and a primary key, what we're showing is we're referring to the actual set name, AMP coverage between the employee and the coverage, and coverage claims is the set between coverage and claims. This works very well. The only thing about it is that it's not typically something that a tool that's generating syntax will generate. But the way you can deal with that is you can wrap that view, you create a view on that query, and then you can query from that view using standard SQL. So that's a very powerful technique, especially for updates. The next level up is what we call table procedures. And these are external programs that can issue native DML as well as many other things. They can be accessed like a table in SQL DML. You can select from them, insert, update, and delete. They return a result set like a table. And these are very useful for encapsulating relationships. This is probably the best way to solve structural problems like occurs depending upon the foreign keys. They can be solved this way, but they can also be solved some other ways. The downside of table procedures is you do need to write you have to write them, so there is some programming involved. But they can be generated with a tool that we provide for free with IDMS called QuickBridge, which generates table procedures from network definitions that allow you to do those insert, update, and deletes on a network record or a record that might be a member of a VIA set. The good thing about table procedures are there's no database or application changes needed. Okay, the next level of technology is something we call referential sets, and this exposes sets as referential constraints, meaning the queries and updates. It's based on actual values, so a primary key would be, it would assume that your record does have something that uniquely locates the record, either a unique calc key or a system-owned index. And that you would then have a foreign key, which is an actual column value in the member record. Okay, well, as you can see where I'm going with this, this is You define this on the network schema set definition. This could require application and database changes because typically we don't have the foreign key value in the member record. But if you were to add that to the member record, you could define that, and then your database, for all practical purposes, would be a complete SQL database with full referential integrity, and it would be completely exposed. The structure of the database would be completely exposed through SQL. So it's kind of like the ultimate solution for converting, making a network database usable through SQL. Well, the reality is that may require application changes, might require restructure, and many customers take a look at this and go, well, that's real nice, but that's just not practical for us to do. So what we delivered in IDMS 19 was something we call virtual foreign keys. Virtual foreign keys also expose sets as referential constraints, but in this case, they're based upon a virtual primary key that we call a row ID, and this row ID is the same type of object that is available for other databases like DB2 and Oracle. In fact, they call it row ID, and they have a data type called row ID. So when you enable this feature on the SQL schema definition, every record that's exposed as a table through that SQL schema now has a virtual primary key, and its name is row ID, and a virtual foreign key for every set in which that record participates as a member. And the name of that virtual foreign key column is FKEY_setName, so that it's easy to understand. No application or database changes are needed to do this, and an important part of this feature is that these virtual primary and virtual foreign keys are visible through the JDBC and ODBC metadata APIs, which means that common tools and application frameworks can now discover the structure of your network database. Okay, so the benefits of this: you can use standard SQL to access and update IDMS. Doing inserts and updates in some cases was a little bit challenging using the set name predicate. So you actually have just about everything you can do with network DNL you can now do with virtual foreign keys. It enables you to write applications using all the popular frameworks, and there's no special IDMS SQL syntax. As I mentioned, you don't need to write any code, you don't need to change your network definitions or change your applications. So this is what our employee demo database might look like with the addition of virtual keys. You see here's the department table, owns the employee table, which owns the expertise table, and the sets, there's sets between them, depth employee and emp expertise, and you can see that each table, network record exposed as a table, has a virtual primary key called row ID, and each table that's a member has a virtual foreign key whose value is the primary key of the owner. Now these are virtual, meaning they don't take up any space on your database, but they are returned when you say select star, and if you issue APIs and say get me all the columns in this table, you'll get those as well. One of the things this does is here's an example of an open source tool that looks at and discovers the structure of relational databases using JDBC. If you point this, if you're not using virtual keys and you try to use this tool with an IDMS database, you'll see an empty screen here, no structure. But when you're using virtual keys, it does discover the complete structure of the database. It kind of looks like a Bachman diagram, even though it's done with SQL. Just to summarize some of these techniques, I know I went through them pretty quickly, but we have extensions, views, procedures, and various types of foreign key implementations. And sort of the important things there is that The extensions and views don't require changes, but they expose the sets in a way, but a little bit limited way. Table procedures require new programs, but no application changes, and you can use those to encapsulate the relationships. And of course, the various techniques to use foreign keys do expose referential constraints. The big difference is virtual keys don't require any programming changes, whereas referential sets do require application changes, although they're slightly more powerful because they use actual data values as the foreign keys rather than virtual keys. Okay, well, now that we can access network databases, we still need to access those network databases from someplace other than the LPAR that they're running on. And this is where the IDMS Server product comes in. It's really IDMS as a server. It really is it really consists of the IDMS open clients that provide ODBC and JDB support, that provide the connectivity from Windows, Windows.net, from Java, using the JDBC driver. From Windows, you can use the ODBC driver from the .NET platform. You can sort of get into native C code and call ODBC directly, or you can use the ODBC.NET provider. You know, one caveat about using the ODBC.NET provider is that it does not directly expose the various types of ODBC handles, so you're limited to the capabilities that the .NET provider provides, whereas if you call ODBC directly, you can take advantage of everything that the ODBC driver provides. Here's just a quick slide to show how the IDMS Server architecture is set up. We have at its core, IDMS is a network DBMS. We have an SQL engine that's very tightly integrated with our network database engine and provides very efficient access using SQL to the existing network databases. On top of that, we have an SQL client interface that is the interface that's used if you were to, say, write a COBOL program and embed SQL in that, or an ads program. And then on top of that, we have our ODBC and JDBC drivers, and they convert our proprietary interface into the industry standard APIs that are used by many tools. Okay, one other thing you can do that since we now have SQL accessing a network database and we now have access through other platforms, you can take advantage of tools that do what are called object relational mapping. This is often referred to as the Java persistence architecture. A common implementation of that is something like Hibernate. And this maps classes are more or less like tables. An object in the Java world or object world is an instantiation of a class. Well, that's a row, it's the occurrence. Objects have attributes. Those are data members. Those are obviously columns. And then there are relationships. Relationship in the Java world or object world are done through references, which are kind of sort of like pointers. And in the relational world, they're done with those who map to referential constraints and foreign keys. Well, it turns out that using SQL and Server, you can actually expose your network set occurrence as Java objects via the SQL query result set. In this case, it shows. I'm not going to go into the details of this, but it turns out that with something like Hibernate, you can actually, and using virtual keys, you can actually generate the Java code that will implement a representation of a network set as a list of Java objects. Okay, switching gears now, we'll talk now a little bit about how you can leverage IDMS application code. Okay, so this is our diagram we saw sort of a subset of before. It shows a couple of different paths to expose existing business logic as APIs. On the right-hand side, we see something that we've already looked at a little bit. That is a web service or API consumer invoking that web service in an application server, typically outside of IDMS, whether that's on ZOS, Linux, or Windows. And that is using SQL and Server to, in this case, we're not talking about accessing data, we're talking about accessing business logic as an SQL procedure. The other approach is using IDMS Web Services, in which case the consumer connects directly to IDMS to execute a web service, or the IDMS application can use IDMS Web Services to invoke a web service someplace else, for example, to call something running in DB2 that's exposed as a web service. And these all work with your existing ways to use existing or COBOL PO1 and ADS programs. Okay, well, there's a number of options for implementing services. You can use the IDMS TCP/IP sockets that was introduced in 16. You can execute IDMS SQL procedures. You can use the IDMS Web Services feature. If you're a CICS user, CICS has very powerful web services capabilities built in. In that case, you're really using IDMS to access the data. And then there are a number of partner solutions that can be used to provide web services. Okay, well, first we'll take a look at using, if you're writing a socket program to, say, use SOAP, you need to specify the request as an XML document, wrap the request in a SOAP envelope, bind that to a protocol, and typically it's HTTP, use TCP/IP to send and receive the request, then unwrap the reply from the SOAP envelope, and then extract the response from the XML document. Customers have done this. It is a perfectly achievable procedure, but it's a fair amount of effort. So the IDMS Web Services feature does most of the heavy lifting for you. So in the case of consuming a web service, the IDMS Web Services feature will handle the adding the SOAP envelope, binding it to HTTP, it makes the socket calls to send and receive the response, and then strips the reply out from the SOAP envelope. The user program really just needs to specify the request as an XML document or extract the response from the XML document. And actually, it doesn't really need to be XML. That payload can be anything you want it to be. It can be JSON, it can be clear text, it can be pretty much anything that you can sort of fit within what would be within the SOAP wrapper. And that basically limits it to, basically I think it really means it just has to be more or less displayable text. But beyond that, it can be anything that makes sense to your application. This was developed and included in IDMS 19.0, and it was included in the portfolio simplification, so all customers that are using current releases of IDMS, meaning IDMS 18.5 or 19, have access to this with no additional licensing fees. And in fact, the code is installed with the with 19.0, it's installed with the base product. Actually, for 18.5, I misspoke. It is not available for 18.5 users, even though portfolio simplification what did apply to that. This is a 19.0 feature. Sorry about that. Okay, so here's just a picture of how that works. We've got the CV and an application server somewhere. The IDMS application program formats a request. I guess I should put quotes around that XML because the request itself, as I said, can be anything. IDMS Web Services will put that in a SOAP request and send that using HTTP to the web service provider, which does whatever it does, database or application code, whatever it's doing, and then sends the response back in a SOAP reply, and we'll receive it over the socket through HTTP, and then pass that back, strip off the envelope, and pass back the payload, whatever it is, to the IDMS application program. Okay, now the other side of things is the service provider, and this is how we use IDMS application business logic. And what we're really trying to do is create APIs, everything in the past we talked about service-oriented architecture and services, and now everything's been kind of rephrased as APIs, and this kind of fits in with the idea that RESTful web services are APIs that are commonly used everywhere, and the various types of API gateways that can be used to discover APIs and provide common endpoints for them. So we're kind of using that terminology now. Well, when you're reusing applications, sort of the biggest issue that comes up is the separation of business logic from presentation logic. In many types of online applications, they're kind of marbled in together, and it can be a little bit of a challenge to fix that. Sometimes if you have components that are really separate, they're a little bit easier to reuse. So you really have to kind of think in terms of small subsets of functionality that can be sort of composed together to provide more general services. Two types of interfaces that we'll talk about. There's the call interface and the presentation interface. And these in CA Web Services, I think they use CI and PI to refer to these. So let's take a look at the call interface. This is really like a remote procedure call. The idea here is that you extract logic from an application. These can be subroutines that are easy to call, mapless dialogues, you can extract some code, and then you can invoke them using a variety of techniques. Socket programs, like sort of the other side of what we just saw for consuming a web service. SQL procedures with IDMS Server is a way to expose these, the IDMS Web Services, and the CICS Web Services, as well as some partner solutions. Okay, well, SQL procedures. This has been available for actually quite a while. It turns out that if you've got an ads mapless dialog or a COBOL program that you can extract, you can define a procedure using the create procedure. Note that that's not a table procedure. That's a regular procedure, very much analogous to a stored procedure for other databases. And these are now directly callable. So you can then implement the web service API on an application server. It's pretty much like the initial diagram we saw, whether that's Java, Tomcat, web application server.net. And then you can, in that application server, you can call the procedure using standard APIs. And that means an SQL call statement that will return output parameters, and optionally they can return result sets. And they're within both ODBC and JDBC, there are APIs that are really specifically designed to support calling procedures. Okay. Another approach is to use IDMS Web Services, where IDMS is the service provider. The IDMS Web Services feature provides an HTTP server and code to deal with the SOAP protocol. A user-written program would implement this service, and what it would do would be extract a request from the payload, which typically would, I guess, be XML that's delivered, process the request. Again, that can be a COBOL program, a mapless dialog, an SQL procedure, any of the ways you can build application code to run in IDMS. Format the response as a document of some format, often XML, but it doesn't necessarily have to be. This is also included in IDMS 19 and is available to all customers. And it kind of looks like this, okay, where we've got the IDMS CV on the right-hand side this time, and because it's being called, the left-hand side we have someone that's consuming a SOAP-based web service, so it'll send a SOAP request. IDMS Web Services will receive the request or HTTP, load the program that you've written that will service that request, strip off the SOAP wrapper, and pass the payload to the application program, and then the application program returns the response, and the Web Services feature then adds the housekeeping to send the SOAP reply back to the application. Okay. Well, the way you do this is we have an API that we provided to do this. It's an IDMS callable service that you can invoke from the supported IDMS languages, COBOL, ADS, PL1, even assembler if you chose to. It's invoked very much like our TCP/IP support is as a callable service, and it provides a number of API functions to transfer data, to manage sort of a session that's sort of open-ended there, and to set various types of options. So here's just an example of, assuming that we have the consumer and provider of both IDMS systems, just a little bit of an idea of how this API might work. On the consumer side, it issues an API function we call initialize to basically do what you would imagine, just to set up the environment. It's kind of analogous to an open. It can manage various types of options like timeouts and things like that. It can send a request using a WS request verb that sends the request over to the provider. And at that point, the timing here is, this is sort of formatted to fit on a slide. The reality would be when you send the request, that's when the provider gets invoked. So it really should be offset a little bit. And he would then initialize the environment, optionally manage options, and then receive the request. The receive the request now it's two separate APIs because you received the request. You know what the user wants you to do, you want to do it, and then you send the response back. Well, the consumer has just been waiting, at this amount of time. And then finally, when you're done, you release resources. Now, the reason we've got this initialize and release is that this is a little bit more general than a standard, stateless service where every request is completely atomic and not related to any others where there's no state. This API is designed so that we could do multiple types of exchanges within the context of a single API, which can be useful, we'll see a little bit later. Well, the other thing that can be done if you're using XML as your payload, there's the idea that we need to parse SQL and generate XML, and generate XML. The IDMS Web Services feature assumes that your payload could be anything you want, and that if you're using XML, one recommended way to do this, to extract, say, the input fields and get them into a data buffer defined by a COBOL data definition, is to use the COBOL XML functions. These were introduced in COBOL for ZOS 3.3. You should compile with, I guess there's an XML SS option to use the system services parser. And as mentioned here, they're supported for PL1 as well as COBOL. And the two functions are parse, which transforms an XML string into COBOL data items, and you can use this to basically extract the data from the request or extract the data from the response, depending upon which side of the service you're working with. And then the XML generate verb, which, if you've got a COBOL data structure, can generate the XML document. And as you could imagine, you could, if you're making a request, this is how you can get the data into XML format. And if you're receiving the, if you're sending the response, this is how you put the reply data. Okay, the other approach that is actually a lot of customers have actually done this very successfully is using the presentation interface, which is sometimes pejoratively referred to as screen scraping. And the essence of this approach is that you find the data in a screen buffer. The brute force way is to use screen geometry. Some tools are a little more sophisticated and they can scan for screen names, which makes it a little bit less fragile. And a big advantage of this is that it avoids the logic separation issue. You don't have to change your application programs. Many customers don't want to touch their ads dialogues or COBOL programs. Well, if you really don't want to touch them, this is one way to avoid touching them. It can be sensitive to application changes, but of course, on the other hand, if you're not touching those application programs, they shouldn't change very often. So it's kind of You know, that's not always as much of a problem as it might appear. And so the way that this is done, but in order to do this, you have to think about what an API does. And an API would provide a complete service that does a user function. And if you think about how online applications work, there are typically a whole bunch of screens that the user invokes in sequence, and there could be some branching logic depending upon what the user wants to do, or in the case of, you know, like adds dialog, you might have function keys that go to different screens depending upon where you are. So you really need to think of each screen as kind of a little microservice, and you need some sort of a scripting capability to tie the screens together and control the flow through the dialogues. You really want to hide all this from the service consumer because they just want to see a simple function that says pay an invoice, you know, look up a supplier or something like that. There are multiple vendor tools are available, and many to do this. Many provide a GUI development environment that you can use to map and link the screens together. Vendors like GT Software, Objects, OBJEX, Postbridge, Rocket Software. There are a lot of tools out there that our customers have used successfully to do this. And this is kind of what it kind of would look like, okay? So on the left-hand side, we have an application or an app, okay, running in a tablet or a smartphone that really wants to, just a very simple request that says pay this invoice. It sends a service request over to some sort of a tool that's acting as the application, you know, sort of the orchestrator, the service orchestrator. And so the API is that simple request that the device sees, and internally within the API provider, if you will, there's a sequence of invocations of online screens. Notice I made them green because they're green screens. Okay, now this there's a whole set of boxes there because it invokes each of these screens, and it may need to do some branching and conditional logic here based upon the results of the screen. So this flow is very, very difficult to predict, so you need logic that can then implement that. And then the end result of invoking all these different types of screens is that you finally have a response that you can send back to the user. So this is what the API is what this, the app sees. The screens are here, they're unchanged, and in the middle you've got tools. Some of the vendors I mentioned have tools that can do these types of things. So this kind of, to just tie it together, here's our diagram that we looked at the beginning. We can see the IDMS Web Services feature. On the one side, we see IDMS SQL and Server providing APIs to introduce SQL procedures or to invoke network databases. And the idea here is that these are various tools that you can use to build web services. So just to wrap up before we have some time for questions, you can see that you can build services based on access to IDMS data, services based on reusing and leveraging IDMS applications, and that this can really help you get more value from IDMS by providing APIs at lower cost and less risk than migrating to another database. So with that, we'll take questions.
Thanks, Dave. Thanks, Dave. Great job as always. For those of you who are on the phone line, if you would like to unmute your line now to ask a question, please feel free to hit #6. For those of you who are listening to this via the audio broadcast, now will be the great time to go ahead and use the Q&A box right in the WebEx. So we'll give you a minute or two to type. Just a reminder once again, we will be publishing a replay of this webcast out in the community, either later today or tomorrow. And yeah, so go ahead and now's the time for questions, folks. All right, Dave, there was actually a question that came in to me privately, so I can go ahead and read this to you. As a reminder, folks, please use the Q&A box rather than the chat. I just happened to see this one. What, if anything, do you need to do to your SQL schema if the DBA adds, deletes records?
Sorry, can you repeat the question? I didn't get the last if.
Sure.
I didn't get the if clause.
What, if anything, do you need to do to your SQL schema if the DBA adds / deletes records?
Basically, you don't really need to do anything other than update your application programs to not access those tables or to access the added tables, because we're using dynamic SQL for most of these types of applications. If you're using IDMS Server, when the schema finds out the records that are in the network database dynamically on the fly. So if you're using Server SQL to discover these things, it will discover them. On the other hand, if you have written and used SQL in a COBOL program or a PL1 program or an ADS dialog, and you've created an access module, so you're not really building web services that are invoked directly from a distributed platform, then you would need to recompile your access modules because you've changed the definitions. But you don't need to do anything to the SQL schema. When you access the network database from the SQL schema dynamically, it finds the records that are defined at that time.
All right, I don't see any other questions coming in, so I think we can go ahead and wrap up. Hold on. One just came in. Hi, David. Is there any service improvements in terms of system administrator's perspective, like any reduction in CPU?
Well, that's I guess that's a difficult question to answer because you've got a little bit of trade-offs. You know, the first one is that if you're using SQL to do the same thing that you did with a network database, because it's dynamic SQL, it actually could use more CPU because it's dynamic SQL and you're actually preparing your statement at the time. So in that sense, if you're trying to do exactly the same thing that you're doing with network DML, it actually might use more CPU. It's like there's nothing faster than using native DML. What you have to really look at, are you able to do things that you couldn't do before rather than do the same thing? And then of course, if you're accessing IDMS from the network, there's more overhead than if you're accessing IDMS from an application running in the CV. So this isn't really a CPU reduction play per se. This is really more you're doing things that you couldn't do before. And in some cases, if you're not doing as much online processing and you're moving that processing itself off platform, then you might see a CPU reduction. But that might be more the case where you're taking your business logic and you're recoding it in Java and just keeping the data intact.
All right, I don't see any other questions coming in, so I think we can go ahead and wrap up. Dave, thanks as always. You always do a great job with these. And I also like to thank everyone who has joined us today. Again, we'll get the replay out in the community later today or tomorrow. So if you have any questions that come to mind later, please feel free to ask them out in the community, and we'll make sure that Dave sees them and responds to them there. All right, have a great day, everybody, and we'll talk to you next time.
Thank you, everyone.